We're Group 18. My name's Janu.
I'm Hanifa.
I'm Anuja.
I'm Paulo.
I'm Yakuza.
I'm Devani.
I'm Lisa.
And I'm Radia.
So in this project, we were tasked to apply the fundamental principles of traffic engineering in order to analyze the existing conditions in a signalized intersection in Burlington, to hopefully be able to improve upon them and design an intersection with optimal traffic flow.
The intersection that we had the opportunity to analyze was Walker's Line and Mainway in Burlington, Ontario. This was a large intersection with multiple lanes, specifically designated protected left turn lanes for all directions, multiple through lanes for both north and south directions, and right turn lanes. By looking at the intersection, we designed an 8-phase signalized intersection with protected left turn phases for all 4 directions.
Through our data collection, which includes the arrival and saturation flow data, we were able to calculate our critical flow for the intersection. Arrival flow was found for all 4 directions, and then by assuming 90% through traffic and 10% left turns, the arrival flow in 8 different directions was obtained, as can be seen in the table. Saturation flow was calculated by counting the number of vehicles that crossed the stop lines for each cycle in each direction of the intersection at 5-second increments. This was only calculated for protected left and through movements, and right turns were neglected. In doing so, however, our initial critical flow value was greater than 1 for the intersection, which is not possible, so we made a few adjustments and took the highest cumulative average for saturation flow. Using the adjusted arrival and saturation flow data, we calculated the lane flow ratio, and finally we were able to get our final critical flow ratio of 0.869.
We determined the cycle length using the physical characteristics of the intersection, and using the calculated critical values, we determined the corresponding green time for each phase. We then formatted this information into a timing phase diagram. In our diagram, we included information about the intergreen and green periods, as well as the pedestrian walk cycle. We made sure to check with pedestrian requirements for through directions, and they were all appropriate. We also checked the queue length developed from our design, and the lengths we found were all appropriate. None of the queue lengths developed will interfere with any surrounding intersections and lanes.
Evidently, we could not estimate the existing pedestrian phase timing for each direction, as the pedestrian signals were not visible from the traffic footage. Due to this, we are only able to partially compare the existing diagram and new design. In the existing design, the cycle length is around 109 seconds. This is smaller when compared to the new design cycle length of 185 seconds. The green time intervals for northbound/southbound through and eastbound/westbound through traffic are more similar in length for the tentative design. In general, the green times are longer and the intergreen periods are smaller in the new design compared to the existing design. The amber intervals are shorter in the tentative plan as well. Moreover, the existing phase diagram has different phase directions from our design. The existing phase diagram starts with a phase with a protected left and through northbound movement, while this never occurs in the phase diagram chosen for the new design. Similarly, a protected phase for the southbound left turn never occurs in the existing design, but is included in our tentative design. Also, the tentative design has a longer queue length, which is expected because our tentative intersection is not actuated, unlike the observed intersection. In summary, there were differences between the tentative design and the existing design in terms of green time interval, amber interval, cycle length, queue length, and individual phases. These differences were expected as the intersection was not designed to be actuated. In conclusion, the project requirement of designing a signalized intersection was fulfilled.